So another common mistake that is done in the repair shop is the use of the wrong material. That is the use of materials of the wrong insulation class. Okay, actually 3 factors are considered when classifying these conductors. Okay, the first, like we said earlier, is the conductor size, as you can see here on your screen. The first is the conductor size, and that conductor size determines the current carrying capacity of that insulated copper wire. Then the second is the thickness of this insulation or the enamel, okay, on the conductor. So that thickness actually determines the breakdown voltage of that particular insulated copper wire. The thicker it is, the higher the breakdown voltage, which means that you can use it in higher voltage environments. Are we getting it? Then the third factor that influences its classification is the kind of material, okay, that is used to insulate the conductor, the type of material used to enamel the conductor. So that type will definitely determine the temperature class of that particular insulated copper wire. Okay, so that temperature class is another factor that we often overlook or we do not put into consideration when selecting these materials. And that temperature class, if you use a material of a wrong temperature class, especially of lower temperature class, okay, you will see that the insulation will be destroyed during normal operations of that asset, the electric motor, generator, or the transformer. So all the materials that you will use, the conductor, the insulating lead rods or insulation papers, what have you, all of these, okay, that you use to line the slots, all of these, they have their own temperature, different temperature classes. So if it is not appropriately selected, you will see that it will affect the integrity of the electric motor or the electrical machines at the end of the day. Okay, so now let us look at how this will affect the operations of the equipment, or rather, let's try to understand these temperature classifications, okay, of the various materials. So for us to do this, we need to understand the nameplate readings or information of the equipment that we are working on. So as you well know, all electric motors, they have nameplates, okay? So it is advisable that you look at the nameplate information and look at the temperature class, okay, that is stated in that nameplate. So if you look at this nameplate on your screen now, you see the insulation class is F, okay? So this is the insulation class of this particular electric motor. Are we getting it? Then we have the normal operating voltage, and then we also have the normal running current. What it means is that this amount of current is expected to run through the conductor windings, okay? So let's look at it now, the insulation class, how it will affect these operations of the electric motor. Now, this, if you look to the right of your screen, you will see the classes, temperature classification of different materials, okay, or the labeling. Like here we have F. What does F stand for? If you look to the right, you will see that F is for 155 degrees Celsius. What it means is that materials that are designed to operate in class F, okay, can withstand temperature or can work comfortably in temperature environment as much as 155 degrees Celsius. This is inclusive of the ambience, okay? Remember, here we have an ambient temperature of 50 degrees Celsius, which means that the material that are used, all the materials that are used inside this particular electric motor that we are looking, or this electrical machine or asset that we are looking, okay, can withstand a temperature rise of about 105 maximally, okay, because 105 plus this 50 ambience will give you 155. So now the danger is this: if I go and use an A class material, a material that is rated as an A, okay, if I go and use it for an F, where I'm supposed to use an F material, you see that the maximum temperature it can actually comfortably stand is about 105. Anything beyond 105 will destroy the insulation of that material. So if I go and use an E, okay, an E class material for in an environment where I'm supposed to use F or H, you see that as the temperature, normal operating temperature, as it's rising to its normal operating level, these materials that are rated or that are classified in all of these insulation class, okay, they will be destroyed in the normal operations of this particular electric motor. So this is one of the mistakes that we do when selecting material. So when you are selecting the insulated copper wire for this motor now, you have to be sure that that insulated copper wire is designed for class F. Are we getting it? Then the insulating lead rod, all the insulators that we are going to use, they are designed for class F, because if it is peradventure, it is subjected to a more stringent operating conditions, your equipment will be safe for you. But if you use a lower class material, that would definitely affect the integrity of your machines. So what it means is that all of these materials, the sleeve rings, okay, the slot liner, this lead rod that we have here, all of these cable, these ties, all of them, they should be able to meet that class F temperature that all class F material will be able to withstand, okay? So if not, you'll see that this insulation will fail, and once it fails, it can cause shorting of the windings. Are we getting it? Or short to ground even, because during normal operations, this particular equipment will be subjected to that amount of temperature. So when you are selecting materials in repairing this electrical equipment or assets, you need to put all of this into consideration, okay? Okay, all of these materials, they must be of the right insulation class, the conductor, the insulating paper or lead rod, okay? Everything, both the rope and what have you that you need, the varnish that you use at the end of the day to impregnate the whatever tie rope you use, or cable tie that you use at the end of the day, all of them should be of that insulation class that is stated on the name plates. Are you getting it? And so that it will be able to withstand the normal operating temperature of the electric motor or the electrical machines.